Hi, welcome to our YouTube channel Rising SSR. In this video, we are going to discuss about SRE, Site Reliability Engineering. There are total 8 modules in this SRE Fundamentals course, but we are going to discuss first 4 modules in this video, and we will upload another video with other 4 modules and also other technical videos soon. So please watch, like and subscribe our channel. Keep watching. Thank you.
Across the industry. So SRE emphasizes on the monitoring, alerting aspects, and how we can ensure that it can be automated as well. Okay, so now SRE has gone above and beyond Google. It's not only Google. Yeah, obviously it came from Google, but it is in its adoption phase. I would say, based on my experience, most of the organizations have started adopting it. Some of the
I
organizations
always help you.
are still improving SRE on a day-to-day basis, right? But yes, the
Utin
theme is that
Atlanali.
it's not only Google, it is way beyond Google. And in next 5 years, 5 to 10 years, it is expected that that is how the industry will operate in a SRE-led way. Okay, so yes, when we talk about SRE, I told you that we are talking about the scalability, availability, the incident response, and the automation aspects. Now, the question is, and it is one of the very important questions and very confusing question as well. Generally, people ask me that, okay, we are talking about DevOps, we are talking about SRE. What exactly the similarity between DevOps and SRE is, and what is the difference between DevOps and SRE? I think those of you who would have undergone
in the right way. But first of all, maybe we should clarify something. What do you think DevOps is, Seth?
So that's a great question, Liz. Back in the day, operators and developers had a lot of contention. Developers used to throw their code over the metaphorical wall, and operators were responsible for keeping that code running in production. Operators had little understanding of the code bases, and developers had little understanding of operational practices. But developers were concerned with shipping code, and operators were concerned with reliability. This misalignment often caused tension within the organization.
All right. Okay. So just remember this fundamental definition. I'm sure most of us who would have experienced object-oriented programming, any language, whether it is Java or .NET, right? We know that what a class is and what is the construct of a class. So you can remember it or visualize it in a way wherein SRE is a class which implements DevOps. So DevOps is an interface. So if you visualize it, if you try to remember it in that way, it makes things very easy. So SRE as a class SRE implements DevOps. Okay. So how exactly it does it, right? That is what we will see. And the fundamental pillars uh, that Google prescribes for um, DevOps is these are the 5 pillars, and please try to remember it by heart because you will definitely get few questions in the examination. And if we remember these 5 pillars about DevOps, then how these 5 pillars are associated with SRE, the visualization and interpretation of that becomes very easy. The, the first pillar is reducing the organizational silo, right? So when we talk about one of the
It's okay.
objectives of DevOps is to reduce the organizational
Atla paddayi
silo,
ante.
basically the silo which used to operate between Dev and Ops, right? Traditionally, DevOps is trying to get rid of that silo. It is trying to integrate the development team with the Ops team, right? Now, when we talk about this particular principle, how how do we visualize where exactly SRE is? So SRE is basically when you see dev team and ops team uh, as a distinct, different entity with their own set of roles and responsibilities, right? Developer using uh, a particular tool, ops team using a different tool, developer using something else, ops team using something else, right? That level of dissimilarity is there. It used to be there. But SRE says that when we talk about reducing the organizational silos, then the SREs should share the ownership with the developers. And there need to be a kind of shared responsibility metrics, right? Which should emphasize on the same, on the adoption of the same tools that the developers use and vice versa. So with that way, the organizational silo can be reduced. Second thing is accepting failure as normal. So if there are any failures, any production incidents or problems, then SREs embrace the risk. They quantify failure, what should I say, in a prescriptive manner. So in SRE, we have a concept of SLO, SLI, that we will be reading as we move on in subsequent chapters. So SRE emphasizes on those principles, and it says that okay, failures has to be accepted as normal. There's no harm in failing as long as we are accepting it in a normal way without any mm, uh, blame game. So there is a principle called as blameless post-mortem. And how do you do that blameless post-mortem, right? Blameless post-mortem, as per the SRE principle, is governed when we implement SLO, SLI, proper monitoring and alerting, and then progress the incident management as per that defined principle. Third pillar is obviously implementing gradual change. And when we talk about implementing gradual change, what exactly it means that rather than going with a big bang approach, uh, can we introduce smaller changes in such a way that mm, it really brings the mindset of dev and ops in a homogeneous state. Right? It should not be that dev thinks that yes, I have to code, ship to production, and ops thinks that oh, these developers are just writing codes and pathetic codes, and it is becoming a nightmare for us to maintain and manage that code in production, right? That mindset has to get rid of, and then only we can build in SRE capability on top of DevOps. Okay, and how do we get rid of that mindset? By implementing slow changes, gradual changes, not a big bang or a massive change in production. Last last two pointers, I mean, it talks about leveraging automation as best as possible. Yeah, automation, all of us know, has become a very important terminology or buzzword across the industry. Everyone talks about automation, automation, and automation. But yes, I mean, we need to understand that automation is great. Not, I mean, there is no disclaimer about it, but at the same time, we also need to understand that not everything can be automated, right? But let us talk in principle. The principle says about we need to leverage automation as best as we can. Uh, and how it helps us? It helps us to reduce something which is called as toil. We will read about toil as we move on in subsequent chapters. Okay. Last but not the least, measurement is the key aspect, right? Any transformation that we think about, right? There are two ways of uh, doing or thinking or implementing any transformation in an organization. Whether you are trying to uh, build some transformation roadmap for DevOps implementation, or whether you are trying to do it for SRE implementation. But one thing which I have learned from my failure is that if you're not measuring it, then it is going to be extremely difficult. So measurement is key for achieving any transformation, any new transformation at workplace. You need to measure that right from the very beginning as it moves upwards in the pipeline. Uh, until production or beyond production as well. You need to measure anything and everything. Then only you will be in a position to quantify the cost benefit analysis. Okay. So that is how so the gist of all these things are that DevOps and SRE are very closely interrelated. SRE needs to be clubbed in at each and every phases of DevOps. If the SRE thought processes are not clubbed in, then DevOps just becomes a buzzword in any industry. Again, a practical experience that I will tell you is um, most of the industry organization they say that they're implementing DevOps, right? When you talk to them, when you start interviewing them, what is your definition of DevOps? They will say that, oh, I'm using GitHub, I'm using Jenkins, I'm using Chef and Puppet. Is that DevOps? To some
It's okay.
extent, yes. So DevOps doesn't mean that if you are using some evolving tools in the industry in your organization, then you can call yourself as DevOps. You cannot. You are not doing justice to DevOps. Yes,
I love
tools
you.
are
I love you.
are the mechanism to help you in your DevOps journey, but using tools doesn't mean that you are 100% DevOps, right? So this is a bit of unfortunate situation happening across the industry. Uh, and I said it is unfortunate because the thought process is mainly tool centric. Companies or people thinking that if I know Jenkins, if I know how to check in, check out the code in GitLab or GitHub, if I know how to create a pipeline, and then yes, I am DevOps. Yeah, but that is an irony. To some extent, it is true, but not definitely true. And when DevOps itself is implemented in a wrong way, then it does blunder to SRE. SRE is implemented as at each and every phases of DevOps, and how it is implemented. We'll be talking about that in details in subsequent chapters. But the essence of telling is, and I'm sharing my experience with you, real life experience with you, that whenever we talk about SRE, firstly, we need to ensure that our fundamentals for DevOps, our fundamental for DevOps pipeline is clear. And once that is clear, once we build a steady state for our DevOps culture, DevOps pipeline, then incorporating SRE
తిన్నానా
principles
వీక్
into that becomes relatively easy. But if our DevOps fundamental itself
వీక్
is shaken up, then SRE implementation becomes relatively challenging and difficult.
So Aniket, DevOps is a super class that SRE is subclass, right? Like we are implementing all the features of DevOps. So DevOps can become a like any other extra things like in the slide I don't see like what SRE has additional features compared to DevOps. Like it highlighted only DevOps pillar.
So it highlighted about the 5 pillars of DevOps, and it also talked about how these 5 pillars of DevOps are related to SRE. Yeah. So,
ghost.
okay, let me go through it one by one. So,
Daddy,
5 pillars of DevOps. One pillar is
you are ghost.
reducing organizational
Nani,
silo,
JJ
right?
Elline.
Uh, this is one of the objective of DevOps, but how is it related to site reliability engineering? How do you reduce organizational silo? From a SRE mindset, the organizational silos are reduced when the dev and the ops team start using the same set or suite of tools or capabilities throughout. Okay, let's say, anyways, we will be talking at length in subsequent chapters, but just for example, let us say that if the developer is using XYZ tool for development, for deployment into the lower environment, can the same tool be used for doing the deployment or doing the configuration management in production as well? So if that is the case, then yes, SRE is something which we are building that culture. homogeneity across the tools. Similarly, accepting failure as normal, right? That's the fundamental principle or pillar for DevOps. So how do we build SRE on top of that? We build SRE on top of that by implementing the culture of blameless postmortem, by ensuring that we set up proper SLOs and SLIs throughout the life cycle, right? If we are in a position to do that, then we are building failure as normal from a SRE mindset, implementing gradual changes. That's one of the objectives of DevOps as well. But from a SRE perspective, how do we do that? We need to ensure that we don't go a big bang release. We follow best deployment or release mechanism. We can follow canary deployment. We can follow blue-green deployment, right? Whatever it is. That way, we are building SRE mindset and capability on top of DevOps. Leveraging tooling and automation, right? It talks about using the same set of tools. There should not be some new set of tools or automation that we generally practice post production. Are we in a position to leverage the same tooling and automation in the pre-production or before production release as well, so that by the time uh, we reach production, we have sufficient knowledge about the tooling and the automation that we have used, and nothing is new when it comes to production, right? The team has got that level of expertise or SLIs built. Then how will we be in a position to to do any measurement? No, we will not be in a position to do any measurement. And whether that measurement is done only post production, or do we have a mechanism to track that measurement in the lower environment as well? So there is a very close coupling between SRE and DevOps, right? As we move across the chapters, we will see how exactly it works out. Hope it is clear.
Yes, okay. So those 5 principles, apart from that, like from the video I heard, like SRE can have their own functions and methods. So will there be any other development tasks which SRE does apart from what DevOps does?
Yes. Don't worry about it. I mean, and this is just the introductory chapter. As we move on, right, I'm sure that it will open a very wider perspective for all of us.
No,
Yeah.
sure. Thank you.
So operations is a software problem, right? So if you see this particular slide, right, that is I mean, everything to do with operations, whether we talk about infrastructure or talk about networking, scalability, resilience, anything that you can think about from an infrastructure perspective, is now based on software, right? So this is the key thing that you can see. Estimates suggest that anywhere between 40 to 90% of the total cost of ownership are incurred after launch, which is right, isn't it? So operations a software problem. In the past world, the thought process was that operation is something which is an entirely different unit for any organization. Developers need not worry about it. There is a separate operations team, or let us say run team, which takes care of all the operational aspect, and it is their headache, right?
I don't know.
Yes, so operation is a software problem, no doubt at all. But
నాది
SRE
అయిపోయింది వాడిది
emphasizes that how we
వెయిట్
bring
చేస్తున్నా
operations early in the
లేజీ
life
గాడు
cycle, so that as a developer, if I'm aware about what
ల్యాప్టాప్
operation
ఓపెన్ చేసినావా
means, what are the challenges that the operation team faces,
నా
right?
నా
If we
ఫోన్
try to
వాట్సాప్
build
బంద్
in
చేసి పెట్టిన
that mindset right from the very beginning, it won't become it will not be a challenge, right?
పొద్దున
Okay,
ఆ వెన్నెల పాప
simple example,
ఏడుస్తుంటే
I'll
వీడు
tell you that
ఏడుస్తుండేమో ఒకేసారి
we
లేచి అనుకుని లప్పల పురికినాం
kick
అప్పటికి
off a
లేచిండు వీడు
particular project and we are into the very first sprint.
లేచిండి
Let us
వీడిని
talk live
తీసుకుపోయేసరికి బయటికి
examples so
ఎమ్మటే
that
లోపలికి
things
పోయింది
are very clear. So in the very
లోపలికి పోయింది
first sprint,
వెన్నెల
let's say that we are talking about developing a login page for internet bank specific application. Right. So everyone talks about, okay, we need to develop the login page. It needs to be developed using, let us say, Node.js. We need to create a page using Node.js. This is the functional requirement that, yes, it needs to have a User ID, it needs to have a password. These are the various functional requirements. Uh, a button for login, it should take to the next page, right? That is the traditional mindset that has been prevailing across. But imagine that if we start that thought process that for that login transaction, right? Uh, uh, this is how our infrastructure would need to be built. We need to have, let's say, if we are talking about cloud, we need to have uh, 5 EC2 instances with this much of CPU, this much of memory, uh, uh, because we need to support, let's say, 5,000 concurrent users, right? So if the thought process starts coming right in sprint one about the volume that we are anticipating, based on that volume, what should be the estimated infrastructure sizing, then just imagine how easy life becomes. Rather than thinking about all these things in sprint 100, which is after 2 years, if that thought process starts coming in right from sprint one, then it is marvelous. So that has been lacking in the industry. That the industry, whether you are delivering using waterfall, whether you are delivering using agile methodology, whether you follow Scrum or Kanban or uh, a squad from Spotify, doesn't matter. Doesn't matter. Don't go by these buzzwords, right? These are just buzzwords. But the key thing is, are you embedding the right practices, right material, right meat, right from the very beginning, right? Are you still functional centered, thinking about functionality without worrying about the non-functional aspects of infrastructure, security, uh, performance, capacity, availability, monitoring, alerting? Are you just thinking about the functionality, or are you trying to build in all these things which are generally operation centric? Are you building all these things right from very beginning? That is what SRE mm, is trying to educate to the industry, right? Which is, don't think operations as a separate problem. Operations obviously is a software problem like development, and it needs to be taken care right from the very beginning. Okay. Now, we will talk about different service levels, what SLO is, what SLI is. But I mean, just from a basic understanding perspective, I would like you to know that SLI is service level indicator, SLO is service level objective, SLA is service level agreement. So whenever we talk about SLA, mostly it is a contractual obligation. It's a business contract. Mm, that comes into effect when the users are so unhappy that you have to compensate them in some fashion or other, right? So don't worry too much about SLI, SLO, because we have a full detailed chapter dedicated to that, and we will be talking about what it is. But yes, service level and measurement of the service level is one of the key principles as well that I wanted you to know.
అయిపోయింది
We talked
అయిపోయింది
about toil.
ఇక్కడ
Again, this
అయిపోయింది
is
అంటున్నా
a
ఇట్
very important concept, and we have
క్యాట్
a full chapter dedicated to toil is. But from this high level understanding perspective, I would like you to know that toil is anything which is a waste. Waste means that, let us say that as a part of our day-to-day activities, we end up doing something which we should not. If certain activities can be automated, right, then uh, we can save a lot of time and effort, right? That is what is toil. Any mundane or any manual activities, right, uh, which can be potentially automated is toil.
ఏమన్నట్లే
So we'll talk about toil as we move on, but at a high level, for a basic fundamental understanding, this is what
క్యాట్
toil
బజ్జీలు
is.
చూస్తున్నాయి
So one of the principles of SRE is how can we reduce
స్పెక్స్
toil as
పెట్టుకున్నాయి
well.
క్యాట్
Automation, yes, obviously. Another fundamental principle that we talked about is related to the DevOps principles as well, how we can find out ways in automation to automate things. So automation and toil are very much correlated, and how they are correlated, I'll tell you briefly. there is something which is called as value stream mapping, VSM. So value stream mapping is a very key concept to really understand the current state of uh, your system. So if, let us say that you are aiming to do some transformation in your organization. If you want to, let us say, improve your uh, uh, capability for non-functional testing in your organization to build in SRE, though you need to do an assessment of the current state, right? And as a part of that assessment, you may have to talk to a lot of people. You may need to have a lot of interviews, lot of questionnaires to understand how the current process is implemented. And once you do the thorough analysis, it will help you to understand where the pain points are, right? Where exactly the waste is. And then once you understand the pain points and the waste, then you think of ways how you can eliminate that to allow you reach the future desired state, right? And then you start implementing it a step by a step. Then you start measuring it a step by a step till the point you reach to your desired state or future desired state. And this is a recursive process until you really achieve your objective. So that is called as value stream mapping. And as a part of this value stream mapping activity, obviously it helps you in understanding toil. And as a part of your toil understanding, you find out the candidates for automation, right? And then you start automating it to start realize and reap the benefits out of it. Reducing the cost of failure, obviously, I mean, uh, how exactly it is correlated, I will tell you. If if any team, so if
SRE specific best practices are not thought of. Let's say that a project or a program is kicked on, and everyone is product feature centric thought process is there. Um, if the aspects related to infrastructure, security, performance, capacity, soul of site reliability engineering, if they are being thought of in the sprint 10 or 15, right? Or if they have not been thought of, right? Because nowadays the mindset is that if I'm implementing something on cloud, be it Google or be it AWS or Azure, right? Oh, I shouldn't worry about anything at all. Cloud is going to take care of me like a baby, right? If my infrastructure is hot, cloud will create another infrastructure for me. Cloud will give me this, cloud will give me that. I mean, majority of the organizations and specifically the leadership team in the organization, they have this mindset, and there is no harm, and it is a right mindset. There are a lot of benefits that cloud provides to really make us tension free from a lot of aspects. But the thing is, it needs lot of considerations, lot of thought processes, lot of uh, ways to implement things so that cloud really helps us uh, uh, in the way we want the cloud to help us, right? And that needs lot of planning, lot of testing to reach to that state. So what I'm trying to say here is that rather than leaving all these things at the very end and uh, start thinking about these things only when we see failures in production, can we not start leveraging that right from day one? Can we not have a set of infrastructure architects, set of security architects, set of cloud architects right from the very beginning who can start thinking about all these aspects of infrastructure, security, design, rather than waiting until the very end and started realizing problem. So if we start doing all these things from the inception, then the cost of failure obviously gets reduced
ఏం చేసినావు
to a very
ఏం
enormous
తాగినావు
extent,
వాటరా
right?
ఇప్పుడు ఇంకా కావాలా
So from a context of this slide perspective, this slide talks about ways how we can improve our MTTR. When I say MTTR, what I mean is mean time
అట్లా
to
అంతే అంతే
recover or mean time to repair. Okay, so just a word of caution: this MTTR is a bit dangerous or tricky a statement because if you see, MTTR has got four flavors. So when we talk about MTTR, we need to be very, very careful if we are talking about mean time to recover or mean time to repair, or are we talking about uh, mean time to uh, respond, or are we talking about mean time to resolve? So R here, the R acronym can stand for recover, repair, resolve, or respond. So whenever we get into any kind of meetings or workshops, right, we need to be very, very careful on what is the version of R that we talk about. Okay. So here from a context of this slide is we need to have that thought process right from the very beginning on how we
వద్దు నాన్న
can
మీటింగ్
design,
ట్రైనింగ్
architect
ట్రైనింగ్
the
నాన్న ట్రైనింగ్లో
components
ఉన్నాయి
of our application, code, or infrastructure in such a way that our mean time to recover and repair is really improved. Shared ownership, yes, that's one of the important concepts. Until and unless we do not share ownership, we will not be in a position to build in this SRE culture, because at the end of the day, we all are human beings. We have been spoiled in the industry in the sense that if I say that I'm a tester, you say that you are a developer, so you will do what a developer does, right? As a developer, your job is that, okay, you know Java J2E, right? You know only to code on Java J2E. You don't know anything on everything beyond your coding skills on Java J2E. So if you have that mindset, if you don't want to evolve that beyond coding, you want to learn about the infrastructural aspects, about the deployment aspects, you want to learn about certain things about how you implement security in your code, then forget about SRE. It is not an easy thing. So we always need to have a shared ownership model for implementing SRE. Uh, if that model is not followed, then it makes things a bit difficult. Now let us. I mean, this is a mind exercise, mind mapping exercise. What do we do every day? What do we do every week? What do we do every now and then? And what we never do, right? Uh, if you get time, just have a think about it, because once we start thinking in this particular process, then only it helps us to understand
ఫినిష్ ఇట్
what is the level of toil that we are doing as a part of our day-to-day activities and how we can get rid
టైగర్
of that toil. Excellent. So the key concept here is, right, if you see, whenever we talk about SRE, 99.9% of
వాటర్ కావాలా
the
తెస్తా
time
ఉంది
SRE is implemented at a scale, right? And when we talk about implementation of SRE at a scale, what do we mean is we are talking about large platforms, about large volume of data sets, about large concurrency, whether it is transactional concurrency, whether it is user concurrency. We are talking about a large set of infrastructure. Okay,
యూ వాంట్ డ్రింక్
so please bear it in mind that SRE is mostly about the implementation at a scale. And this is one very important concept, very
ఎనఫ్
important
ఇది తాగు ఇది తిను
point to remember from an examination perspective as well. You might be asked about this in your exam. So SRE implementation at a scale is the key thing that you need to remember about, and that is what the case story the concept from the case story. That's the derivation from this. Okay. Now, let us.
So, Aniket, so one of the five pillars is that implement gradual changes, right?
Mhm.
And now here we are talking about SRE changes, challenges of scale is always a good one. What does it, how does it correlate?
Both are entirely different things.
Mhm.
So, one, we are talking about implementing gradual changes, right? So, gradual changes doesn't mean that we are talking about a very big application. But the thing is, if you see the traditional way of implementing that big application into production is that you have developed it for 1.5 years, right? And then at the end of 1.5 year, when the development is complete, then you follow a big bang release deployment into production. That is what we used to do traditionally, isn't it? We have a project, a small project running for 6 months to 1 year, and once the project is complete, the testing is complete, we deploy that in production with a big bang release. 2 nights, 3 nights, all of us will be awaken. We will go into a war room meeting. All of us will flock together into the
Finish it.
office. Pizza will be ordered
Amma,
overnight. Coke will be
better
ordered, right? And all of us
faster.
will get into the deployment, right?
Work
And
చేస్తున్నాను.
thinking God that, oh my God, please give us the blessing. Everything should be all right. There should not be any issues, right? That's the traditional way of doing thing. What DevOps says that do what SRE says, clubbed with DevOps, is do a gradual change rather than waiting for 1 year or 8 months or 6 months for having a big bang.
Last.
If
అయిపోయినాయి.
we
Good
implement
job.
functionality in chunks, smaller pieces, and do a gradual release and a slow release to production, we don't need to worry about having a big bang change and sleepless nights, right? So that is one scale. And the correlation is that we are not saying that we are doing it for a small, it is a still we are doing it at a scale, very big application, right? Very big infrastructure, very big number of users, but we are doing it in a phased way in a smaller increment. So both of these are entirely different concepts, but they are interrelated. Don't assume that if we are doing anything in a smaller chunk, that is not big. That is also big, and that is the reason we are doing it in a smaller chunks. Yeah.
Understood. Thanks.
So Aniket, I have a question. So
Hmm.
when we talk about scalability, like SRE plays a major role in deciding the whether the service has to go on the scalability, like that uh, decision will be taken care by the SRE, whether
That is right. So
yeah.
traditionally, I mean, we had a separate team, infrastructure team or a storage team, right? They have been given the responsibility that yes, you need to take care of
ఇది
the
ఎక్కడ పోయింది
infrastructure
ఇక్కడ
capacity
పెట్టేది
sizing and scaling. And what SRE says that
ఇందాక ఇది ఆహా
uh, can we? It's not important concept for a site reliability engineer, right? So I think before I go ahead, I'd like to understand any of your thought process or whatever understanding you have. What do you know about SLOs? Any of you, please. So for some example about service level objective, and in the example that you can see in front of your screen, right? This is about availability of 99.9% of web requests. www.xyz.com per month should be successful. So when we say that 99.9% of web requests in a month should be successful, this is a service level objective. Let us imagine a situation that you are getting 1 million uh, web requests in that particular month. So what does that SLO mean? 99.9% successful means that you are giving a leeway of 0.1% for unsuccessful requests, right? So if you have 1 million hits or 1 million web requests coming in 1 month duration, it means that you are allowing the system that as long as the failure is 1000, which is 0.1% or less than 1000, you are okay. You don't need to worry about, right? That is what is called as error budget. So whenever you define a service level objective, there is always an error budget associated with the service level objective. And that error budget is nothing, but it is the leeway. It is the leeway that you are granting, that if the system is within that leeway, I don't need to worry about. But the moment the system starts going beyond that threshold, then definitely I need to worry about. Definitely I need to take some action to ensure that I bring back the SLO to its normal situation. That is called as error policy, error budget policy. So in this example, your SLO is 99.9% of the incoming web requests should be successful within a month. That is your service level objective, which gives birth to an error budget of 0.1%, that out of 1 million incoming requests, you are setting a leeway that if the failure rate is less than or equal to 1000, yes, you are absolutely fine. Your organization is absolutely fine. Your business is absolutely fine. No more questions, no more challenges. But the moment case, there needs to be a policy which is called as error budget policy that needs to be
Yes.
implemented to ensure that the policy is really adhered to, and whatever the actions as per the policy mandates, the organization needs to adhere to that, implement that, and bring back the error budget back to normal. Yeah. So this is one of the example wherein we are talking about the web requests. We'll talk about another flavor, another example, which will make the concept a bit more clearer. So in this example, we are talking about the login transaction, right? So average login rate of 1000 per hour in a 31-day period for a month, which equates to roughly around 744,000 login in a particular month. So let us say that we need to define a SLO for that. 44,000 login transactions within 31 days. We are um, expecting not more than 7,440 logins to fail. Right? That is the threshold that we have set. Okay, but the moment if we start experiencing that instead of 7,440, if 8,000 transactions are failing or 10,000 login transactions are failing within 1 month, that raises an alarm, right? We are breaching our SLO, we are breaching our error budget. And then what is the error budget policy? Simple example of error budget policy is that let us say that instead of 7,440, if you are having 8,000, then it means because you're telos. So obviously nothing is new. I think all of us know about that. In case if if the business misses the SLO, then obviously there will be a revenue loss. Uh, there will be drop in the employee productivity, will be the business will be losing customers. And nowadays with social engineering or social media being in high, it won't take even seconds to have things exposed on internet, right? Social media backlash, that is what we call it as. So bank's ATM goes down, if it's not that much of a problem in India. But here in the UK, I've seen that, let us say that for XYZ bank, if the internet goes down for five minutes or for half an hour, it's gone. I mean, the very next day, because I work for a bank, I can see that the very next day, a lot of customers they shift the bank from bank A to bank B. That is how they work. Uh, so it is basically loss of business, in case if the SLOs are missed, and that is one of the business drivers that, with the scale of evolving volumes, or with the scale of people using internet for doing business, right? Companies now don't have that luxury. Everyone wants to be as much reliable as possible, and that is something which is making site reliability engineering more in demand.
See, I'm in training. If you want anything, you can drop the mail.
Consequences: there will be no new feature launches allowed.
GTPL
Sprint
support,
planning may
GTPLM
only
support.
pull
You can
post-mortem
write in the
action items from
details
the
again.
backlog.
Actually, I'm in
Software
training. Okay.
development team. Okay, this is the simple example that I told you, that in case if a error budget is violated, then as per the policy, what generally Google does. So Google generally implements this error policy. Uh, no new feature launches are allowed if the error budget is violated. The ongoing sprint planning is stopped then and there, and that post-mortem action items are being updated into the backlog, and the sprint team takes care of that. Okay, that is how they do it. Another example of availability, uh, all of you who are especially into production support or ops, I'm very sure that you know about 99.9. We call it as three nines. 99.99 is 4 nines. So 2939495 nines. That is the way, that is the metrics in which availability is defined. So in this case, 99.9%, it means what? It means that every month it allows you 43 minutes of outages, which is your error budget. So if you are defining your availability as
Morning
99.9%,
breakfast.
it means that in a month, as long as your downtime is confined to 43 minutes or less than 43 minutes, then you are good. So what you can do within that 43 minutes is any new features that you need to deploy that may need a requirement, doesn't mean that you need to bring down your infrastructure for 43 minutes every month. Why? Some of you who are very close to microservice based architecture uh, and its implementation on Docker or Kubernetes, you may very well know that for deploying any new feature, you don't need to bring down your infrastructure. You can do it in a dynamic mode. So if you have to deploy uh, one new microservice, you can deploy that microservice on the fly. Or let us say that if you have to make some code changes into that microservice, right? You can do it on the fly without the user noticing it, because that is the flexibility which
Why?
tools like Terraform, or which technologies like microservices or tools like
నేను బజ్జున్నా
Kubernetes
మన ఇంట్లో
allows you to do, right?
బజ్జన్ ఇస్తాను.
I'll tell you a live example how it is done as we move on. But just for your information, uh, you don't even need 43 minutes of downtime, although you have set it up, which is a different thing. But uh, it depends on whether you are leveraging on-prem deployment, or are you doing cloud deployment. So for cloud, for containers, that has become a lot easier nowadays.
For any of the SLAs or SLOs, we always the planned downtimes, right? We always calculate outside the window, right? Never considered as downtime.
No, that is what SRE emphasizes. That, see, the thing is, we make rules to follow it. So if my availability SLO is that I need to have my application available for 3 nines, which is 99.9%. That equates to 43 minutes in a month, which means that if I'm tracking it in a very neutral way, in a very accurate way, anything that I am going to do from a deployment perspective or from a patching perspective or from a servicing perspective, it needs to be within that 43 minutes. The moment I exceed 43 minutes, it means that I'm breaching my SLO. So one of the key objectives here is that SRE emphasizes is let us be very realistic in setting that SLO. And once we set that, let us aim to uh, start adhere to that and religiously obey that. Yeah.
Yeah.
Okay, so let us read about this case.
Sure.
We won't always be able to pinpoint the service at
Part of this case study is it's a clear message that SLOs needs to set across the business. So it is not only the DevOps team or the SRE team, right, who can who is responsible for setting SLOs. There needs to be a wider stakeholder involvement. And when I say wider stakeholder involvement, it includes business, which is I would say the essence of SLO, and all of us. I would request that please learn it by heart. This is called as the valid dimension of service level objective. And when we talk about valid, right, the key thing from a service level objective setting perspective that we always need to focus is the first thing is V, which stands for volume, right? So when we
Ranjay,
talk about volume, we need to be very, very clear and thoughtful about, are we talking about user volume? Are we talking about transactional volume? And in both the cases, right, irrespective of it is user or transactional volume, number of transactions and users, because for these three different cases of volumes, uh, we will have we will need to think about uh, different SLOs. For example, we are talking about peak number of concurrent users as 1000. It means that, let us say that opens up their Outlook, whether it is uh, web Outlook or right. So that's the peak time when almost everyone in an organization, let us say that 1000 employees in an organization, mm, everyone tries to access Outlook. So that's the uh, peak number of becomes a bit constant. So from that time onwards, maybe out of 1000, only 500 employees keep checking their emails regularly on after or let's say every 5 minutes or 10 minutes. So we need to be very clear about
do you want?
what's the peak concurrency, what is the actions for all the dependencies would need to be taken care of. Consideration for cloud related dependencies should be taken care of, and then only understanding about latency. Anyone?
The time it takes to read and process the data.
Right.
Delay in response time.
Yes, agreed. So now let us talk about response time and then latency. So response time, basically, if you see, right, from my browser, the moment if I open, if I um, try to open a particular website, www.xyz.com. So the moment I type the URL and click enter, as soon as I click enter, right, what happens is, if you visualize it from a network perspective, if you visualize it from a OSI reference model, which is
Almond,
the
put that
networking model,
there.
right? What happens is the first byte of the request, it starts flowing from my browser and it starts traveling to the server, right? Server receives that request, it starts processing, and it sends back the response. So the response is being sent to my browser. The moment the first byte of the request leaves my browser till the time the last byte of the response reaches to my browser, that is called as end-to-end response time, in very plain English, very simple layman's language. So that's called the end-to-end response time. So what will happen here is that if uh, the network is really fast, then your end-to-end response time will be really fast, right? But let's say that if you are working on a slow network, right? And if you got a end-to-end response time, let us say of 10 seconds, okay? Then your server might have responded in just 5 seconds. The server is efficient enough. It might have responded within 5 seconds, but the remaining 5 seconds of the time is consumed in your network, right? That is what is called as latency. The overhead
Tintawa?
that internal intranet network
Ammadi tinatlet.
bandwidth is not that great. It has not been designed to cope up or to cater for the volume of traffic. Or second flavor is you are talking to some third parties wherein again traffic from your server goes to the third party. So that network is also considered into the overall latency. So there are a lot of factors of it, but overall latency is basically an overhead, okay, uh, that is built on top of the genuine or the desired response time. Okay, so that's the L for the valid. E stands for errors, right? And those errors can be any kind of errors, right? It can be errors related to your application code. It can be errors related to your application configuration. It can be errors related to your infrastructure. You can think of anything and everything related to errors. When you think it from your application perspective, you have 5 HTTP 500, 404, 400, 200, right? Uh, when you think it from your configuration perspective, it can be errors related to your thread pool setting, related to your connection pool setting, related to anything. I mean, it can be deadlocks. When you think it from your infra perspective, it can be CPU, memory, disk, IO utilization related errors, or database related errors, database contention or deadlock related errors. I mean, just at a high level, I'm telling you, people who are into a particular technology, into a particular area of expertise, they will know that, I mean, each and every technology and the piece of code that we write or the piece of infrastructure that we leverage has got different errors. But the end of all this is, are we really having SLO for those, right? We should not have SLOs for any and every error. It is not possible at all. But at least the key errors, based on experience, are we setting SLO for that? And last but not the least, tickets, which is a key part of our incident management journey. So are we tracking our tickets, right? Do we have SLOs for our incident management, various processes that we do in our incident management, right? So the valid dimension, just I'd request all the participants to please learn it by heart because it is very important. Okay.
So only setting up the target, right? Usually SLA, what we calculate is we'll have a, like if you look at the volume, we say that 99.99% is what we'll put as a target, right? In a typical SLA calculation methodology. So here, not only the overall target, and also we are putting a condition, right? We are saying that 99.99% succeeded with 200. Okay.
Mm-hmm.
So that, and also if you look at the availability, what we are saying is address downtime issues, and all with the condition zero downtime deployments.
Yeah.
So that means sometimes even in the volume scenario, even you achieve 99.99%, and if your issues are goes beyond 200, right? That means you're still not added to the SLO, right?
Let me clarify. I mean, I get your confusion. So just see it very closely. We are talking about SLO, we are talking about error budget, and the third column talks about policy,
Mm-hmm.
right? So here for availability, you are defining a SLO, and then you are defining an error budget, and then you are defining what is the policy that needs to be followed if the error budget is violated.
Okay.
Yeah. I mean, can you be a bit more uh,
Yes, sure,
clear on
maybe.
what your confusion is?
So on the availability, so we are 99.9% of the overall availability of a service.
Hmm.
But if we have a downtime, right, because of a deployment, that
That's right.
means did we met the SLO or not?
No. So now, if you are setting up 99.9% three nines, which means that you can have a downtime of 43 minutes in a month.
Mm-hmm.
So as long as your downtime is confined within that 43 minutes window, you are adhering to your SLO. But
Okay.
the
Mm-hmm.
moment your downtime exceeds more than 43 minutes, it means that your SLO and your error budget is violated.
So if you have one error, deployment error, right? Um, and if you still within 43 minutes of overall downtime,
Yeah,
that means we are meeting the SLO.
exactly. Exactly.
So yeah, so I'm confused about the zero downtime deployments, right? That condition. So yeah, that's where I'm trying to
Okay,
get
I
more
get
clarity.
that. So don't be confused. So that is
Mhm.
where I told you, right? I mean, uh, the zero downtime deployment is mainly a policy that you can set up. So let us say
Mm.
that if your SLO is violated, if you are taking more than 43 minutes in a month, right? It means your error budget is violated. You need to do something to ensure that you are within 43 minutes. And what will you do? You can set up a policy of zero downtime deployment.
Okay, that's not a
That is
Sir,
what
measurement
how did
criteria
we
basically.
calculate that 43 minutes?
we will, and that is the next chapter when we talk about SLI, service level indicator. That is how it is calculated. So once we go to the next chapter and when we talk about service level indicator, uh, that's where you'll gain a bit more insight on how we calculate that and how it really helps us to understand whether we are meeting it or not. So Srinivas, to answer
Yeah,
your question, zero downtime deployment is a policy.
not a
When
measurement.
we, yes, and that policy, if you remember, I took that example that let us say that if we are following, mm, uh, if we are using Kubernetes or microservice based architecture, those kind of architecture helps us with a zero downtime deployment. We don't need to worry about downtime.
Understand.
Okay.
Okay, thank you.
If we are adopting cloud-based infrastructure, right, we don't need to worry about downtime at all because there are a lot of things that we can do in a dynamic way on the fly.
Yeah,
Okay. But yes, if we are still using traditional on-prem infrastructure, traditional deployment mechanism, then yes, we cannot have this zero downtime. We will have to have a downtime.
agree.
Yeah.
Example, same example. See, like for example, is this downtown is for one particular server, but we will be having a backup server for the same thing, right? So actually, the service won't be down.
మమ్మీ
So how do we consider that in this particular example?
We do consider that, you're right. So
Yeah.
your downtime is structured not only considering that your service is up and running on one server or one leg of production. So when you design your SLOs for 99.9%, you have designed it considering your DR capability, considering your failover capability as well. Yeah. So it is not like that you design your SLO just assuming that your application is just running on one production site or one leg of production. You always consider your DR capability, that in the case that if my application is running hot hot or hot cold or hot standby. So let us say that if your application is running hot and standby, right? If your primary data center goes down, then do you have that capability that within 43 minutes your standby data center is up and active, running again and serving the user? If you are able to do that
Yeah.
within 43 minutes, then yes, your SLO
Yeah.
is. So
Yeah.
what I'm trying to say here, Sopan, is that when a SLO is designed, that takes into consideration all the design aspects at infrastructure level, at an data center level, at a cloud level, at an availability zone level, at a multi-region level. This is where SREs plays a very critical role. So with all these understandings about the infrastructure blueprint, with the understanding of the operational requirements aligned with the infrastructure blueprint, you will be in a position to set up right SLOs. But if uh, that understanding is not there, Swapan, if people have no understanding uh, how the dots are joined from an infrastructure blueprint perspective or recoverability perspective or DR, whether it is RPO, RTO perspective, then it makes things very difficult.
Right.
All right.
Yeah. Thanks.
Excellent. So let us attempt module 2 quiz. SLO is an acronym for what?
Service level
Service
objective.
level
Service level
Service level
objective.
objective.
Which of these is not a recognized SLO?
full cost of ownership, total cost of ownership.
Excellent. Latency is?
The time taken for a
Take
response.
response to between the deliver to a user.
Risk of an error budget being exceeded.
Big bang release.
Big Bang rejected all HTTP requests.
That's that's right. The benefit of adopting SLOs in conjugation with your users is what? How important it is, right? So that is where you can correlate that the flavors of this question and how exactly it is related to the content in the slide. So it is just giving you a kind of hint on from exam perspective how exactly you need to have the visualization of the various slides. All right. So fine, we have done module 3 and I think we answered it, right? Yeah.
Okay, yeah.
Good. So module 3 is about reducing toil. So what we are going to talk about, we are going to talk about the toil associated with site reliability engineering. Now, Vivek, and he is a very famous personality from Google. On LinkedIn, there are a lot of posts that he generally writes on a regular basis. Uh, and according to him, toil is a kind of work tied to running a production service that tends to be manual, repetitive, automatable, tactical, and devoid of enduring value. So as you can see, as we move to the subsequent slides, we can talk about uh, these aspects of toil. Uh, but the first book, I mean, if you remember the site reliability engineering book, uh, the very first chapter that we see there as well, there is a chapter in eliminating toil, and this gentleman has a lot of contribution in writing for that particular chapter of eliminating toil. And he has written a separate book as well, um site reliability engineering. And I do remember what was the title of the book. It says it was How Google Runs Production System. So in that book, he has written a separate chapter for eliminating toil. So from that perspective,
అయినా
he's a very well-known
గూగుల్లో వర్క్
personality.
చేస్తే ఆయన
So as we move down, right, in this chapter,
నేను
you can
బ్యాంక్ ఆఫ్
see
అమెరికా కదా
what
ఆయన
exactly
గూగుల్లో
toil is. Work is a toil if it is manual in nature, right? So if it is manual in nature, and specifically, let's talk about
గూగుల్లో వర్క్
manual
చేస్తే
or
అతను వివేక్ అంట
semi-manual releases, connecting to infrastructure to check something in a trick from an exam perspective. You can see questions in the exam. For example, you can see the 3 pointers over here, right? They can give you a question uh, uh, with all these three options completely copied, and they'll add one more option, the fourth option, and they'll tell you, which of these options are manual toil, or which of these three op three options are not manual toil, or one option, questions like that. From that perspective, especially these items which are color coded, right? And just try to remember that so that it helps you in choosing the right option from exam perspective. So if you see these um, examples, they are considered as a toil
manual,
because they are
repetitive,
manual in
automable,
nature. Now,
targeted,
from a
learned,
deployment
repetitive,
perspective,
scalable.
uh, gone are the days wherein we used to have manual deployment, right? Now, if any organization is really adopting DevOps, then everything is orchestrated, everything is automated from a deployment perspective, right? Uh, Now, connecting to infrastructure, another example that you can see, right, um, is, I mean, infrastructure as a service is the new concept that has been evolving. So if organizations are using infrastructure as a service or infrastructure as a code, uh, mainly infrastructure as a code, then in that case, you don't need to even worry about mm, creating infrastructure in a manual
ఆయన
way, right?
టీచింగ్ చేస్తున్నాయి
Everything is
ఆయన టీచర్ నౌ
just by the click of the mouse. You just need to create an account for the cloud service provider, and you need to just enroll your credit card details or debit card details so that says.
నీ టీచర్ నువ్వు
But what
స్కూల్కి
I'm
వెళ్తే
trying to
ఉంటాయి
say is
స్కూల్కి
log
వెళ్తావా
into AWS
వెళ్ళాలి
console or GCP
నాన్న
console,
ఆన్లైన్లో అటెండ్ అవుతున్నా
and whatever you want, you just need to know that. If you want a Linux server, a Windows server, or any whatever infrastructure you want, just select that, select what your configuration that you want, and just apply within matter of seconds or minutes. Your infrastructure is provisioned, right? It's not like the old days of automation. I mean, repetition and automatable, they are very closely related. So anything which is repetitive in nature is a toil, right? Simple example. Let us say that monthly release, right? So release one is today, 3rd of March. Release 2 is 3rd of April, something like that. So if you
ఆయన
wrote
గూగుల్లో
a
వర్క్
piece
చేస్తాయి
of
అని
code
చెప్పినాగా
for release 1, uh, and the same piece of code, the same piece of testing you need to do for release 2 as well, because release 2 will be a combination of release 1 plus the new functionality in release 2. It means that if you have to perform a thorough testing for release 2, obviously you have to include release 1 candidates as well into your testing suite. So are you repeating the same thing that you did in release 2, release 1? If you are repeating the same thing, it means that you're not adding much value, because uh, if you
రిషి
would have automated that, then that would have yielded a lot of value. So the thing is, do we have the thought process wherein we identify that if we are
ఐఎమ్
following a release
యు
based
ఆర్ టైగర్
approach, so I have got from release 1
యు
to
ఆర్
release
లయన్
10. So can I
ఎలిఫెంట్
find out a way in which for release
హిప్పో
2, I am in a position to
రైనో
automate things that release 1, whatever I created, whatever automation pack I created, I can reuse that for release 2. The same thing, I can reuse that for release 3, and so on and so forth, right? That is what, from a testing perspective, right? Or if you are getting the same alert, let's say that every morning you are getting an alert saying that your CPU is running 90%, 90%. It's a repetitive alert that you get every morning, right?
Nana teacher.
What are you doing to solve it? Have you automated it, right? Do you have a mechanism in place that if you are getting that alert, there is an automated system in place which really helps to take care of that remediation activities, right? We'll talk about all these things as we move on, because monitoring, alerting is one of the key things which is a part of this curriculum training. But yes, we need to understand that anything which is repetitive in nature is a candidate for trial. The third thing is anything which is automatable, but we have not automated that. Uh, is a trial. So anything which is automatable is always a trial. Mm. Examples in this slide is physical meetings to approve production deployments. I'm very sure that most of us would have gone through these pain or is still going through these pains, right? We have got the cab approval process, right? So in the cab approval process, I mean, a lot of people flock together. There are a lot of people who have no awareness about a particular the days. Do we really need those kind of cab meetings? No, we don't, right? Why why are we not in a position to bring that level of intelligence into our system, into our CI/CD pipeline itself, right? So if we are, and I'll talk to you what CI/CD pipeline is in case if some of you are not aware of DevOps and the pipeline strategy. As we move on, I'll talk about that so that your concept is clear. But at this point of time, I just want you to know that instead of having that bureaucratic approach wherein 10, 20, 30, 40 people log into a cab meeting and certain people take the decision, okay, go, no go decision, live, no live decision, right? Can we not bring in that level of intelligence into our pipeline itself? That the pipeline is intelligent enough that yes, it is a go or a no go. I don't need that cab meeting at all, right? Um, so those kind of things can be eliminated in the current state. If you see, these kind of things are basically toil, right? So work is a toil if it is automatable, but I mean, we know that it is automatable and we are not taking any actions to make it automatable. Tactical is a very famous word, right? Most of us, we use that. So generally what happens is that in case if we see any problems, but let's say any production incidents, our first thought process is that, oh, let us think of something. Okay, this is the problem, this is the resolution, uh, and if I need to go ahead with this resolution in a strategic way, it is going to take a lot of pain, lot of effort. It will take 2 months, 3 months to implement. Let us find out a shortcut approach. Let us find out a tactical approach, right? Which is a kind of workaround which helps you to get rid of that problem on a momentarily or a tactical basis. So that is something. If
పడ్డాను
we go ahead
అనిపిస్తున్నావా?
with that shortcut approach, it is a toil. It is a toil because it will reoccur again. You'll again have to find out a shortcut approach. So that recurrence frequency is there, which is going to really uh, make things uh, consume a lot of time. So anything which is tactical in nature is always a toil. No enduring value. This is a very important acronym that I request you to please remember. Uh, Enduring value is what? Whatever things we talked about, whether it is manual in nature, tactical in nature, whether it is repetitive in nature, automatable in nature, all these things, if you see, it doesn't have an enduring value. So enduring value, although is a separate topic that we can see, but anything which is manual in nature, it has got no enduring value, right? Anything which is repetitive in nature, it has got no enduring value. Anything which is automatable in nature, but we are not automating it, it has got no enduring value. And the same thing is for tactical. Anything which is tactical, right, which is going to exist momentarily, it has got no enduring value. So enduring value means any value add that we are thinking from a strategic perspective, from a perspective of reaping the good cost benefit analysis. That is what is called as enduring value. Work is a toil if it has no enduring value. But the moment we build in that intelligence into the work, that we start extracting value from that, it has an enduring value. So that is what it is. And finally, linear scaling. Uh, Work is a toil if it is scaling linearly. And how do you correlate it? You can correlate it that let us assume that uh, um, you have to build an infrastructure for a key project or a program, and that needs, let's say, 100 components, 100 servers set up, maybe 50 web servers, 30 app servers, and 10 DB servers, right? Total 100 servers you have to provision, right? So if you see, the pain point that you need to go through is you have to first analyze, okay, that, okay, to meet the demands, the volume, I need 100. Then you have to decide whether you need Windows server, Linux server, IBM server, or the flavor of servers, the hardware. Then you have to present that to your steering committee that this is, the steering committee will approve it. Then it will go to the infrastructure team. Infrastructure team will do the estimation of the cost. Then that cost estimated would need to be approved by someone from the finance team. And finally, with all the pains, right, is the next pain. You will give the purchase order to the vendor. The vendor will say that I will take 4 weeks, 6 weeks, 8 weeks, right? Then the vendor will deliver it to your data center. Once it is delivered, then you need to start configuring those servers into your data center, installing operating system, installing the application software, right? Making it ready, configuring it as per the processes and policies, and finally then you deploy the code on that. Just imagine all the pains, right? And the pain increases in a linear way. So if you have to do it for 10 servers, your pain is less, 20 pain is more, 30 pain is more, 100 pain is even far more, right? So it is a toil. But instead, if you are trying to leverage, or if you are in the adoption of infrastructure as a code, nothing to worry about. Just if you have to spend 100 servers, right? If you know what kind of servers you need, what should be their capacity, CPU, memory, what should be the application software deployed on that, right? Just you can either go with infrastructure as a service offering from the cloud, or you can go with platform as a service offering from the cloud. So when you go with infrastructure as a service, right, you can create infrastructure dynamically on the click of a button, click of a mouse. If you want to go with platform as a service, the infrastructure together with the application software comes free as a package, right? You just need to know what you need to create, and everything you can create just by the click of the mouse, right? So that is what it is trying to say, that any work which is linear scaling in nature is always a toil, it is a pain. And with the technological advancements that we have now, we can get rid of that. But at the same time, we need to remember that you cannot say something as a toil if you don't like doing that, For example, certain things you personally don't like doing it, right? So you cannot say that as a toil. Or your regular day-to-day activities, right? You come to the office, you log into your machine, you launch all the needed tools to do your day-to-day activity. That you cannot call it as a toil, right? That is something which you have to do, for sure, in order to do your perform your duties. If you need to arrange a meeting, a physical meeting, a face-to-face meeting, or any workshop, right? That is not a toil, because if you need to do a meeting, if you need to meet people to brainstorm, to share ideas, to uh, identify issues, resolve issues in the form of face-to-face meetings, or you cannot call that as a toil, right? That is not toil. So we need to be clear on these aspects as well. Now, why is toil bad? I think all of us know why it is bad, but just in a structured way. It slows down the progress. Nothing new in that. Definitely, anything which is manual in nature, repetitive in nature, it slows down the progress. It reduces the velocity of the work, right? It has an impact on the quality of the work as well, right? Because we as human beings, if we do something manually, there is always a risk that human errors can be introduced. But if we try to automate that, computers are less likely to contribute to the errors, right? And eventually the quality of the output increases. Career stagnation, if we keep on doing, and that is what we all have been facing, right? Going to the office and doing the same thing daily, weekly, monthly, yearly, at some point of time we lose that kind of enthusiasm. We feel that, oh, what the hell I'm doing, right? Let me think of and find out
My
something new,
teacher,
which 10, 15, 20 years
నీ స్కూల్
when we had
మాదపూర్లు ఉంటాయి
our uh,
అండ్
data
వాసవి దగ్గర
center,
కూడా ఉంటాయి నీ స్కూల్.
we started with physical servers, right? It was a concept that yes, we have a data center. Within a data center, we install, we deploy, we configure a lot of physical servers, right? That was a kind of boom situation that yes, we have a data center, we have got X number of physical servers, right, on which our applications are up and running. But after some time, we felt that, oh my God, these physical servers are pain. Pain in the sense that I have got one physical server, and in that physical server, let us say that I have got 100 CPUs and 100 gig of RAM. I have an application running onto that, but I realized that my application is just consuming 25% of the resource. So remaining 75% of my resource is getting wasted, right? So when the industry started experiencing that, then they came up with the concept of virtualization or virtual servers, so that whatever was a waste in the physical server can be utilized. Then it was a boom. Virtualization was a boom, right? Whether it is virtualizing your Microsoft infrastructure, Microsoft server, or whether it is virtualizing your Unix server, right? Now, different tools came which helped in virtualizing and which helped in making the best use of the server. So virtualization is basically a concept here. I mean, in the example that I told you, you using the virtualization software, I can create a number of different virtual servers on my physical machine. So when I know that out of 100 CPU and 100 gig, my application is just using 25%, it means that only 25 CPUs are used and 25 gig of RAM is used. Then I can create 4 virtual servers within the same, 25 each. And I can deploy 4 different applications into each virtual servers or each logical partitions, right? So that was an evolution. What I'm saying is that when we were living in the physical server world, right, we were very happy. But over a period of time, we realized that physical servers has also got some toil. Then came the concept of virtualization to get rid of that toil, right? But now I'll tell you the story again. Virtualization also started becoming painful over a period of time. Why? Because virtualization is not as efficient, as performing as fast as physical servers are. Virtual servers are relatively slow. Second point is that you have virtualized, you have created 4 virtual servers in a physical server, but you need to again buy additional operating system licenses, because you need 4 different licenses for operating system if you have to install that into 4 servers. That is again a very costly business. It increases the OPEX as well as the CAPEX, right? So you have issues related to OPEX and CAPEX, you have issues related to performance, you have issues related to management, because you need dedicated professionals who have knowledge about virtualization and the tools and the technologies. So over a period of time, right, whatever was a blessing for us started turning into a toil. And now of late, that virtualization concept, virtual servers concept is taken up by containerization, which is a boom now,
Yes.
right? So containerization solves the problem of virtualization. We don't need to worry about. It is very light. It's a light,
నిజమ్మా
right? You don't need a separate operating system
అవును
license for that,
ఇందాక
because
నిజం
containers share
కిటికీ
the same operating system image onto which your physical machine or virtual
జస్ట్
machine is
ఫర్
built,
ఫన్ కిడ్డింగ్
right? So whatever was a blessing, virtualization was a blessing at some point of time, it has become a kind
గివ్ మీ
of
వన్
toil now,
ఈట్
and that toil is something which is overcome by containerization. But now, what after containerization? We need to wait and watch. So that is why it is being said here
ఈట్
that it is an unending process. It is an unending process. I have told you this practical live example of the evolution, right? Specifically from an infrastructure perspective. There are many, many other examples as well. But the gist of this example, to narrate this in the form of a story, was to tell you that yes, it is an unending process. And last but not least, it causes burnout. Yeah. Engineering bankruptcy. How many of you have heard of this term, bankruptcy? Okay, let me explain to you. This is, I mean, some of you who are holding a very senior leadership role, right? I think that you need to know about this. Before I go ahead with this, right? Have you heard about technical debt or technical debt? Any of you? Right, because there is a very close correlation between technical debt and engineering bankruptcy. Okay, so yeah, go on, Srinivas.
Yeah, basically technical debt is if your solution is
Found engagement, and the objective was to build in a product for. So because it was a complete re-engineering, they wanted to re-engineering the invest money in people who has that security knowledge and mindset, right? We need to do frequent testing, whether it is static testing or dynamic testing or interactive testing. So if we are doing it release after release after release after release, right, then obviously it incurs a lot of cost. Okay, so there were a lot of senior stakeholders who didn't agree to me specifically from a cost perspective, right? The thought process prevailing in the industry that from a security perspective, at the very end, if you do penetration testing, that's all, right? Let me do penetration testing and let the vendor who does penetration testing submit a report, all is well, that's fine. First release, they didn't care about because of cost. Second release, they didn't care. Third release, I mean, it continued for almost 6 months, right? Uh, Out of interest, what I had to do, and it was just a kind of proof of concept, right? In the very sixth release, I framed a small team just as an investment from the organization, 2-member team together with me, and we started doing the static application security testing and dynamic application security testing. And in the sixth release, we identified more than 500 flaws, 500 defects, right? As an outcome of static, dynamic, interactive testing, as an outcome of infrastructure vulnerability scanning, right? And I just wanted to grab that opportunity to educate the stakeholders that uh, uh, you should not neglect security. And sometimes what happens is that if you try educating based on the theoretical concepts, right, people just ignore it, right? But when you have data to prove or to substantiate your theoretical concept, in that case people don't have any reason to challenge you and to neglect you. So this time I thought, okay, fine, my theoretical knowledge is not yielding much. Let me change my thought process and my uh, way of actioning. When it was a half an hour, half a day session workshop, and in that half a day, when I walked through the 500 plus security vulnerabilities so far, that since past 8-9 months, the developers had no clue about, then it was an eye opener for all the senior stakeholders, including the CISO, including the CTO, right? And that is what now I'm translating it, what exactly technical debt is. So if we could have done the needed security assessment testing in release 1, we could have identified issues, we could have resolved it. Then absolute zero debt. The same thing could have done in release 2, release 3, release 4, release 5, release 6. But because it was not done, all the bugs and the defects, it kept on accumulating. And when we see it in technical terms, that is what is called as technical debt. Right. So if I quantify the outcome of all those 500 defects, and if I try to measure that in terms of money, let's say that if all those 500 defects are carried to production, and if I have 500 production incidents in a day, and if it takes 500 man days to reverse back and resolve that, right? If you try translating that into money, it is hundreds and thousands of dollars or pounds, right? So over a period of time, if you are not taking care of something which you definitely need to take care of from a testing perspective or from a design perspective, over a period of time, neglecting that, it creates a pot of technical debt. And that accumulation becomes so huge, so big after a period of time that it leaves you nowhere. You completely get bankrupt. And that is what is called as technical or engineering bankruptcy. Okay. So from that perspective, it is very important that we need to build in that SRE culture supplemented with DevOps, that we should always be in a position to take care of paying the technical debt at the right point of time. Okay. And that should not bring in us into a situation wherein we are on the verge of engineering or technical bankruptcy. I hope that clarifies things.
Yes, pretty much.
Yeah. So I mean, that is my personal thought. When we try to correlate things with experience rather than just going through the words and through the slides and PPTs, right? It makes any training, any discussion more lively, more interactive. So I hope you like it. But in case if you don't like it, please don't feel hesitated. Let me know. Okay. So SRE is what happens when you ask a software engineer to design an operations team. Yeah. Okay, guys, I think continue after this. The first thing is obviously it requires a lot of engineering time. When we talk about engineering time, right? What exactly, what are the various activities that we need to think about? We need to think about the external automation, the internal automation, and enhancing the service in such a way that the services do not require any intervention. From an exam perspective, I can not guarantee you, but there is a very high likelihood that you will get one question from this. Generally, they ask the question that from a toil perspective, right? Uh, they'll give you choices like external automation, internal automation, enhancing the service, or something else, right? And they can ask you a few questions related to that. So kindly remember these things. I think we talked external automation is basically uh, if we think of any automation that can be done externally to a particular tool or a particular service in order to automate something. It can be anything depending on the nature or the functionality. Internal automation is most of the SaaS products or COTS product nowadays, right? They come up with some inbuilt automation functionalities, right? For example, let us take the case of database, right? Even if you are using any flavor of database, the most dominant ones are Oracle or SQL Server, right? They have got their own automation capability of database failover or failback or database restore or database backup. So those internal capabilities, automation capabilities are built in within the tool itself, within the software itself, right? Or enhancing the service, right? If we have got a service, if we have got a monitoring service, right, which we are monitoring on a manual way, right? Can we enhance that service and bring in that level of automation so that the service tells us once it reaches certain thresholds? So those kind of things which we'll be reading in subsequent chapters, but can we take care of or think about all these aspects? Okay, so making engineering time available, again, it talks about the concept of a 50-50 split, 50% of the time engineering time on ops work and 50% of the engineering time on toil related work. At least 50% of each SRE's time should be spent on engineering project work that will either reduce the future toil or add service features. So this 50% rule, it ensures that one team or person does not become the ops team. That is the fundamental principle behind that. And it is an average to reflect the real world scenario, right? It may vary from organization to organization. Some organizations which are into their adoption phase, you cannot expect that organization to blindly go ahead and follow this, citing that no, is implementing that and Google is educating on this, so I need to follow that. No, it's not a hardcore thing, right? Google does it because it has been doing it since past almost 1.5 to 2 decades, but that doesn't mean that every organization which is keen in the adoption of SRE, they need to do it right from day one, right? They should not. And we'll talk about the various delivery models of SRE, the way in which organization have started adopting that in subsequent chapters. But the essence of telling this is, yes, although it is a best practice recommended by Google, but uh, as long as organization starts adopting it, even in 0 100 5 95 10 90 ratio, right, it has to be an incremental start. This is the example for Slack, how they went with the SRE adoption, right? So I would request, okay, Srini, if
Yeah, moving towards SRE at Slack. Slack moved from 100 AWS instances to 15,000 instances over 4 years. Excessive toil caused by low quality, noisy alerting. Ops teams were so consumed by interrupt driven toil that they were unable to make progress on improving reliability. Slack explicitly committed to the importance of reliability over feature velocity. Operational ownership of services pushed back into the dev teams, resulting in the teams making the code fixes necessary to stop the incident alerts.
that is right. So I mean, it briefly talks about the SRE adoption journey for Slack, wherein as a part of their AWS adoption. It talks about how they scaled up from 100 to 15,000 AWS instances, and as a part of that, they underwent a very painful experience. There were a lot of noisy alerts which the ops team had to deal with. So at some point of time, they established that kind of shared responsibility metrics between the ops team and between the dev team, that they identified ways how to limit the noisy alerts, how to have only meaningful alerts. Uh, and the emphasis is over a due period of time, due course of time, they adopted the SRE ways of working. Now, question, very important question. I think we briefly touch based on that. Automation. Everyone talks about automation, but is it worth automating everything? Right? There can be certain activities which obviously, yes, we can automate, but at the end of the day, what we have to analyze is we have to do a cost benefit analysis, right? Whether the cost benefit analysis is really making a particular uh, situation as an as a candidate for automation. If the cost benefit analysis doesn't permit doing that, then there is no point in automating that at all. So from that perspective, I mean, this is a very complicated example. And if I have to be honest, right, I did try to find out the best possible way to interpret it over the internet, but I couldn't, right? But at the same time, the way in which I have interpreted it based on some inputs from the DevOps Institute trainers is, I will explain to you. But let me tell you, it may vary from person to person, how they analyze and interpret this particular chart. So this is a graphical analysis, and you can see, right, you have got x-axis, you have got a y-axis. So in this example, what the objective here to communicate is that, let's say that if you do something every week and it takes you just 1 minute to do it, on the y-axis you can see 1 minute, and against that 1 minute 4 hours is encircled, right, in red. Okay, and on the x-axis you can see that it is weekly, right? So let's say that this 4 hours is nothing, but it is the budget to automate that task. So the thing is, you have been given a budget of 4 hours uh, to solve something. That is basically your error budget, or you can say that that's the SLO, that 4 hours is something that within 4 hours you need to fix a particular incident. And let's say that that incident happens on a weekly basis, and it takes just 1 minute to fix that incident. So the thing is, something which we know is happening on a weekly basis, and if I have to manually go ahead and fix that, it is just going to take 1 minute of my time, right? And uh, the SLO that I have been given, or the leeway that I have been given, or the budget that I have been given is 4 hours. So considering this situation, there are two options. One option is that, yes, you find out a way to automate that, right? You can do that if the automation is pretty simple, pretty straightforward. There is no harm in automating that. But if the automation for this particular scenario is going to take a considerable amount of time and a considerable amount of effort, is it really worth automating that? In my opinion, no, because even if you have to manually go ahead and fix this on a weekly basis, it is just going to take 1 minute or 2 minutes of your time. So when you're going to do it manually, it is just going to take 1 or 2 minutes of your time on a weekly basis. There's no point in investing time and money. So the gist of the entire thing is that when we have to uh, identify that to reduce toil, what are the candidates that we need to automate? What are the candidates that we can live up with? What are the candidates that cannot be automated? There needs to be a very thorough due diligence and analysis at a work stream level, at a feature team level, right? Then only that yields the benefit. Otherwise, there is no point. Now, let us talk about this case study from Accenture. This case story is self-speaking. So the key concept here is, I mean, Adobe is Accenture DevOps team, DevOps platform, basically. Uh, we can see that the team supporting Adobe globally were basically inundated with large number of tickets, and they were close to the point of their engineering bankruptcy. That is where this particular concept was instrumented. This was followed, and which really helped them to reduce toil and again become productive. So let us attempt the module 3 quiz. Which of these is an example of toil?
Manual deployments.
Amazing, awesome. Engineering bankruptcy is when?
I think B.
Remember the 50-50 ratio?
Work. Yeah, engineer work 100%.
Exactly, yes. So you always need to remember that 50-50% ratio. Which of these approaches can be used to reduce toil? Yes, we can automate that. Very true. So that finishes module 3, and module 4, wherein we will talk about service level indicators, and the monitoring aspect is a really very important module. Uh, so let us talk about module 4. Now, some of you had the questions, right? That if the SLO is violated, or if the error budget is violated, then how do we know that? And this is the answer to your question. We know that by having service level indicators, by monitoring that, right? So we are going to read that very closely in this particular chapter. So what SLIs are? SLI stand for service level indicator, and they are ways for engineers to communicate quantitative data about systems, right? So far, we have been talking about a lot of quality aspects. When we talk about SLO, right, we always talk about quality, that yes, 90%, 99%, or XYZ%. But now we are going to see how we can quantify the qualitative aspects from a quantitative perspective. So service level indicators are basically the mechanism to translate the quantitative aspect of measurement to allow us really uh, analyze things and come to a conclusion. So that is what SLIs are. Now we will talk about few examples which will really make our fundamentals very clear. So in this example, if you can see, please relate it with the previous example that we talked about SLO. So about 99.9% of the web request per month should be successful. So here, if you see, this is a standard service level objective, right? And this service level objective, right, uh, means that we have a threshold, we have a leeway, we have error budget that out of 1 million requests, 1,000 requests can fail, right? We know about that, right? So we are very clear about SLO. We are very clear about error budget. Now, what is SLI in this case? So please pay attention. We are talking about 99.9% of what? Of web requests, right? And that web requests will be what? They will be the incoming HTTP requests, right? So our focal point is that if we measure the incoming HTTP requests to our web server, then we are going to effectively measure whether the SLO is met or not met. So in this example, the service level indicator is your web request, your HTTP, incoming HTTP request, right? So if we think of a mechanism, how do we monitor the HTTP request, the incoming web requests? Then it means that we have chosen a particular indicator, and now the next step is how do we monitor that particular indicator? Yeah. So on what do you want to monitor? Another example, which okay, it's another example. Let us say that uh, let us talk about some technical examples. Let us talk about some non-technical examples. So technical example, you saw the number of HTTP requests, right? Another technical example is that mm, you have a SLO of response time for a particular transaction, which is 5 seconds, right? So in this case, if you are monitoring the response time at a transaction level, right, your response time is the indicator, is the service level indicator, right? So you need to track the response time for any transaction or every transaction or whatever transaction you are really interested to understand whether it is meeting your SLO or not. So in this case, you'll be monitoring your transaction response time. If you are keen to monitor the throughput, say, let's say that if you have a login transaction and you want to measure that the throughput is always less than equal to 5,000 transactions per second or 10,000 transactions per second. So in that case, your uh, mm, indicator, service level indicator is the throughput or the transactional rate or the hits per second, right? You can have other technical indicators, SLIs. Let us say if you want to monitor your underlying infrastructure in terms of the CPU utilization or memory utilization or disk or IO or anything that you can think of, right? So these are the indicators that you can use for monitoring against a particular service level objective. So you can set up a service level objective that my CPU should not uh, go beyond 80%, right? That is your service level objective. So how you are meeting this, how you are monitoring this service level
Naka,
objective? For monitoring this, you have to monitor the
బుజ్జి
CPU
క్రీమ్ది
utilization
బయటికి
the uh, for one server or for it is for a suite of servers, right? Now let us talk it from a business perspective. Business will say that, come on, I'm not worried about all these technical things because I don't understand all these things. I am worried about that if my user, let's say we are talking about online banking application, and the objective of the business is to understand that the uh, user, let's say in one day, there should not be any failure, or there should be not more than 5 failures when the user is doing uh, bank transfer, right? How are you tracking that? So again, you have to track the uh, success rate or the failure rate of your money transaction or your bank transfer transaction. So you're tracking it at a business process level, which is your bank transaction, and you're tracking that in a day how many bank transactions are happening, and out of X number of bank transactions, out of X number of bank transfers, how many are successful and how many are failures. So here you can see that you are bringing in a business insight for your service level indicator. So your indicator is number of successful bank transfers, number of failed bank transfers, and how you are going to monitor it. Obviously, you will have to monitor this particular transaction. You will have to monitor that when a user initiates this transaction, whether it is a HTTP 200, which is a pass, or whether it is a HTTP 400, 500, or whatever it is, which is a fail, right? So it can be service level indicators can be technical in nature, which really helps the technical team, the developers, the ops team to really understand where the issue is, what the issue is, how it can be rectified. And if it is business in nature, it really helps the business to understand that whether the business objectives have been fulfilled or there are issues. And then in case if there are issues, then obviously that helps the technical team to further look into that issue. Yeah. Now comes the important concept of monitoring. So we have got service level indicators defined. Absolutely correct, no doubt at all.
వాడి దగ్గర పెట్టిపోతుంది
Understand
నేను
and
తెత్తలే వాటర్ కావాలంటే
analyze whether the SLOs have been met, and
వాడి
the
ఇలా చేస్తే
underlying of
పిచ్చి పిచ్చి అవుతుంది.
all the SLO and SLI that we talked about so far is monitoring. So monitoring is a very key concept and term that a site reliability engineer should definitely be aware of. And we will talk about what monitoring exactly is. People, some of you who have background in the monitoring aspects, you will know that very well. And I would encourage you that please share your experiences on top of whatever I'm going to narrate based on my experience.
ఇది కొత్తది
People who are
వేసుకోండి.
not much close to monitoring, for them, yes, it is definitely going to be interesting. So monitoring is nothing. I mean, you have a SLO set, you have identified the service level indicators. Now, how exactly you uh, leverage that service level indicator? Until and unless you do not have a monitoring capability, you will not be able to do that. And that monitoring capability is something which once upon a time was pretty much manual in nature. We used to instrument the code at some point of time to extract the monitoring details. For example, let us say that if I'm writing a code and in that code I'm writing a for loop, if I need to really understand how much time the for loop is going to take, then I will have a timestamp before and after the for loop, execute the code, and that will give me the timestamp. I mean, I'm talking about long time ago when we didn't had much of a tooling in place to really help us in monitoring. But over a decade or so, we have tremendous progress in the monitoring area. We have got a lot of tools, lot of COTS product, which has really helped a lot in the monitoring aspects. Okay, so we are going to talk about those monitoring tools, monitoring utilities, or the COTS product. Now, before we talk about any monitoring tools and utility, right, we need to understand one important terminology, which is called as telemetry. Telemetry is a combination of two different independent words, tele and metry. Tele is nothing but it is remote, and metry is nothing but it is measurement. So if we want to do any measurement, perform any measurement in a remote way, that is what telemetry is. And most of the tools that is very much widely used in the industry, in most of the uh, mostly banking and financial sector, for which I'm very closely associated with, most of the tools that are being used, and the most extensively used tools nowadays since past almost 5 to 10 years, is Dynatrace. So Dynatrace is one of the monitoring tools, and that also works on the concept of telemetry. Okay, another tool you can, I mean, AppScan. You have which is another monitoring tool. Mostly it is used for security. That is also based on telemetry. Splunk is used on telemetry. You have App Dynamics, which is based on telemetry. So, I mean, any tool that you can visualize, that you can think of, which is APM. APM stands for Application Performance Management. And that's the standard name which is used for these suite of tools. But at the end of the day, if you see, and if you see the core functionality of these tools, they help mostly in the monitoring aspects. All these tools. Okay, so all these tools follow this concept of telemetry, and what this concept of telemetry is, uh, we'll talk about in this slide. So generally, I mean, if I tell you the example back in 2004 or 5, that was the time when Dynatrace came into picture, right? 2004, 5, yeah, nearly about that time. So that time, I mean, APM was evolving. Dynatrace was one of the first APM utilities which completely changed the dynamics of the market from a monitoring perspective, and it was really good. And how it was initially evolved was, let us say that, and it used to be thick client in the sense that you can have Dynatrace product on a CD-ROM, or you can download that from their portal, buy the license of it. Uh, you need to download that product on your machine, which is your Dynatrace server, you can call it as, or you can call it as the Dynatrace engine. So let's say that I have installed a Dynatrace engine on my machine, right? And I need to monitor an Apple Mac machine, right? So I'm just taking a very simple example, right? So in the traditional ways, or even it is operational now as well, what I will do is uh, I know now that I have to monitor two machines. Simple thing. I just want to monitor how much to monitor. Very simple example. So what Dynatrace will do is Dynatrace will say that, okay, fine, just let me know what machine, which operating system do you want to monitor. Uh, I'll tell that, yes, I want to monitor one Windows and one Mac operating system. So it will say that, okay, fine, not a problem. These are the agents that I am giving to you. What you need to do is you need to just uh, I will deploy one agent which is used for Microsoft monitoring on Srini's machine. I will configure the Dynatrace server, which is residing on my laptop, to talk to those two machines remotely. So that is just the configurational aspect. It is not that complicated, but people who would have configured any of the APM tools in your data center, you know that, right? At a high level, just for your visualization and understanding. So I have got my Dynatrace server. And when I install that Dynatrace server on my machine, on my laptop, what it does is it installs all the components. That is, it has got an inbuilt database as well, right? And from my server, I just need to configure the IP address of Srini's machine. These configurational aspects are of their machines, and it will communicate, start getting logged into the database, which is on Dynatrace server. And over a period of time, all the data gets uh, uh, stored, persisted into the database. Now, there's another component called as Dynatrace client, right? I can configure that to run in the URL, or I can open a Dynatrace client, a local thick client. And then using that Dynatrace client, if I need to analyze that over last 5 hours or 6 hours, how does the memory look like? Get that plotted out, charted out. I can create a dashboard, right? So this is what telemetry is, right? This is what remote monitoring is. Now, whatever concept I told you is an obsolete concept, right? Nowadays, Dynatrace is cloud-based, so you don't even need to install it on your local machine. You just you can configure Dynatrace for monitoring. Just it is monitoring as a service, right? You just need to understand what you need to monitor, what is the underlying hardware that you need to monitor, what is the application software that you need to monitor, what are the IP addresses, where exactly the servers are sitting, and just with a click of the mouse, you can do all these things on Dynatrace web admin portal. That's all. So when you do that, I mean, Dynatrace takes care of all the configurational aspects. Obviously, you need to be aware of the technicalities because it is a vast area. Dynatrace has got its own exhaustive training and certification path, right? There are experts and champions who are Dynatrace administrators, who are Dynatrace config experts, who uh, configure various flavors of monitoring depending on the organizational needs. So that is an entirely different area altogether. If you want to be really expert and knowledgeable in that, then you just need to pursue that in its entirety. But whatever I'm telling you, it as a very conceptual, very high level, right? So if you want to explore further, you might want to, and depending on what your organization uses, if they use Dynatrace or App Dynamics or SolarWinds or any XYZ tool, right? So all these tools provides you with the flexibility of doing infrastructure monitoring, application monitoring, monitoring of the underlying application softwares other than your code. You can create synthetic monitors as well, depending on certain conditions. You can set up thresholds, right? For example, if you want your CPU utilization as soon as it reaches 80% or exceeds 80%, you can set up thresholds to create an alert, and you can configure your monitoring system to talk to an alerting system. For example, if you have ServiceNow as your alerting system in your organization, so you can marry Dynatrace, which is your monitoring system, to ServiceNow, so that automatically, as soon as the thresholds are reached, an automated ticket gets created for the in ServiceNow that raises an alert to a particular set of team to immediately action on it, right? Uh, and it's not only ServiceNow, right? You can configure it to a lot of, I mean, nowadays, most of the organization wants to do things on real time, right? So they have got Slack, right? You can create a Slack channel, and in that Slack channel, you can configure the alert so that someone who is constantly, regularly monitoring the Slack channel, he can get notified and he can action on it. You can configure it to Microsoft Teams, whatever it is, right? So the dynamics is changing. It depends on the nature of uh, the application, nature of the alerting strategy that is there in your organization. There are multiple tools. The industry is spoiled, if I have to be honest. So many tools are there that it will really make you worried what is happening. Which tools should I use? Which tools should I not use? But again, every tool has got its pros and cons, and you definitely need to first of all understand the organizational priority. What is the monitoring priority? What is the monitoring strategy for your organization? And considering that monitoring strategy, which is the tool which gives you the most benefit, right? Obviously, cost is one aspect. Every APM tool, every monitoring tool has got its own licensing cost. So you need to do an analysis of the cost aspect as well, in case if you are into leadership role, and you need to ensure that cost wise you need to make your investment aligned with your budget. Some of the tools, right, Splunk, Prometheus, Grafana, CollectD, all these are the tools for monitoring. I mean, monitoring these tools, Grafana is used to plot chart graphs. CollectD, same thing. Then logging nowadays, most of the company they use Logstash. There is another thing, Kibana logging as well, which is very prevalent nowadays. Most of the companies have started using Kibana because it has got some machine learning capabilities as well. And Dynatrace is why I'm emphasizing, because of late, since past couple of years, Dynatrace has come up with AI ops concept. So they are trying to building artificial intelligence within the tool. So with that artificial intelligence and machine learning capability, there are a lot of things that the tool does by itself. Uh, and as we move on, I'll tell few live examples that I have experienced and seen with my eyes, which is really good. I have not seen that level of any level of AI or machine learning in other tools. what Dynatrace is building. So they're really very competitive in the market, far ahead than other vendors. We need to make sure that monitoring is effective without drowning in a sea of non-actionable alerts. The path to success is to instrument everything, but only monitor what truly matters. And that's what we are saying, that we talked about it very briefly, that monitoring is absolutely fine. But the thing is, what are we monitoring? It should not be that uh, I am sitting at home and I have configured my alert on phone, and every second I'm getting an alert, getting an alert, getting an alert. So I'll be drowned in the sea of alerts, right? What we need to do is we need to ensure that the alert is really something which is meaningful. I don't want to understand every minute what the CPU utilization on my web server is. What I need to understand is that if the CPU utilization goes beyond 90%, then only I get a notification, so that the importance of alerting is not diluted. So you have to build in that culture in your organization wherein, I mean, yes, I mean, alerting wise, you can alert everything and anything, right? If you go ahead with that motto, it means that you are diluting the importance of alerting. People will think, oh, it keeps on coming. But what will happen is that in that sea of alerts, right, there can be one really important alert which needs your attention, and because your mindset is, oh, it keeps on coming, going, let me not worry about it. So it will get lost. So that is why configuring alerting only for something which really needs an immediate attention is very much needed. It should be an actionable alert, okay, which um, can be actioned. All right. So if
Am I audible?
yes, you are.
Yeah. My job is to make Trivago products faster for customers accessing our services anywhere on the globe. Our SLOs focus on hotel search response times, not on specific parts of our service or technology stack. You can only improve SLOs that you can measure, and digital end user perspective monitoring using tools like Catchpoint allow us to check that our hotel search response time indicator is delivering our SLO benefits. SLOs focused on the user experience, not tech, can spot performance issues with an ISP or CDN anywhere in the world. Data collected by monitoring is used in diagnostics, RCA, feedback loop to dev teams results in optimal resolution.
Uh, Case story, if I have to summarize, is um, it is talking about making a DevOps feedback loop. If you see, right, Trivago, what used to happen previously, that the hotel search response time were taking too long, as too many hotels were being returned per search. Uh, because too many hotels were being returned per search, right, the end user would need to wait for some time, right, which really made the users frustrated. So what Trivago did was, they have fixed the number of search, rather than, I mean, when the customer is trying to search for a particular hotel based on his condition, right, Trivago will just go ahead and it will limit it to 10 or 20, and as soon as 10 and 20 is searched, because 10 and 20 search is relatively easy, as soon as 10 is searched, it will throw it out on the screen of the user, and behind the scene it will go ahead and search another thing, right? I'm basically implementing the pagination concept, or implementing the background concept as um, uh, to take care of the user experience, right? So this is the very tricky part, and that you can do only when you implement a particular monitoring mechanism, particular SLO, as a part of your monitoring. Otherwise, you will not be able to do that. Observability is one of the, I mean, we have talked about monitoring, we have talked about SLO, we have talked about SLI, we have talked about monitoring, but now I just wanted to let you know that definitely need to know about all these things, but the modern world in which we need to speak about all these things is something which is called as observability. Observability, right? It is basically you are monitoring the quantitative data that you have for monitoring. What is your analysis and interpretation from that? That is what is observability. What are you observing? Right? You can build in a dashboard for Dynatrace, which will give you fancy charts, fancy graphs, which will give you a lot of data. But what is the outcome from that? What are the observable elements from that? Right? From which you really need to decipher meaningful output. That is why, that is what observability is. And in terms of why it is important, let us briefly talk about observability is important because the rate at which business growth is increasing is massive in almost all the organization, right? The volumes are increasing. User volumes, transactional volumes, user concurrency, transactional concurrency, throughput, everything is increasing. The scalability of the infrastructure is increasing. We are transcending from a monolithic to a microservice based architecture. We are not living in the world of physical servers or virtual servers. We are talking about container workload management. We are talking about monitoring of the Kubernetes um, cluster, right? When we talk about microservice based architecture, there is a lot of dependency of one microservice talking to another microservice, right? But last but not the least, on top of all these, the customer expectations are changing. People are losing patience. They don't have patience nowadays, right? Our generation have got at least a bit of patience, but if you see the young generation, right, they don't have patience. If internet is slow, and the moment they see a whirling in front of their screen, they start losing the patience, right? So imagine, I mean, it's basically a deterioration of human behavior, wherein people don't even have patience for few seconds and few minutes. And when that patience level is breached, then it causes reputational damage to business, right? Uh, so that is what customer experience is on top of that. So for taking care of all of these, if we do not build in proper observability mechanism, then uh, it is not going to solve the purpose. Now, uh, observability equates to better alerting. Now, a live example, which I quoted, and I will try to correlate that now. We talked about we need to eliminate a lot of noisy alerts. Yes, we need to. But from an observability perspective, how do we correlate it? Right. So let us talk about that example again, that we are monitoring a particular web server for its uh, CPU utilization, right? So CPU utilization is our service level indicator that is monitored. Let's say we are monitoring that using that. So SLO is there that it should not reach 90%. SLI is